Hey everybody, this video has been sponsored by iFixit. More on them later in the video. Hey everybody, Adam Savage with Norm Chan here in the cave. We have an interesting one today.
We're doing a teardown. That's
We
right.
are. We are doing a teardown of this bot from Obi-Wan Kenobi.
Yes, that's right.
I was like going to say Mandalorian because I'm on automatic pilot with Star Wars.
So this is Lola, of course, from Obi-Wan Kenobi. Hasbro makes this the Lola animatronic version, and I can kind of activate it by petting it, so it comes alive. And like the show, it's like a companion robot, right? So I'm just looking at it. We just put the batteries in, watching it move, and just see like what is it that makes it feel alive? What are the motions?
Well, one thing is it doesn't ever raise and drop the wings at the exact same cadence. There's always a little bit of a difference between them, which is one of those things that just feels a little more analog. Secondly, it's clearly responding to some voice. How are you?
Yeah, all right.
That was a response.
Yeah, there's a microphone I see right there. So yeah, and looking at how many actual like movement axes it does.
We got one wing, we got a second wing.
There it goes. And like you said,
independently. There's this telescoping here.
Yeah. Let's see. Hey Lola, can you show me that movement? I don't think there's any speech recognition. I think it's just activate. There it goes. Yeah, so yeah, it kind of
raises and lowers. The hamburger opens up, and then there's pivoting here on this business.
Yeah, on the base.
Am I right about that?
I think so. I think I noticed that too. Yep, there it goes. Yeah, a little bit of a tilt.
Oh wow! So the entire thing that the stand sticks into is a moving little platform.
Is a little tilt, which is kind of like a puppy dog head tilt.
So there's something about this toy. First of all, its functionality is really lovely, but it's actually bigger than the shooting prop.
Yeah, I think this is about like 50% bigger, which they have to accommodate for electronics they're putting inside here.
Even though we can make stuff really, really small, when it comes to something as a limited form factor as this, we're still going to end up having. They still had to end up making it a little larger to get that functionality.
Yeah. And playable, for kids to handhold and feel like it's going to be interactive. But I'm so curious about what's on the inside.
Yeah.
So let's take it apart.
Yeah, let's do it. I'm going to pull it off of the base here.
Yep,
just
those legs. There it goes. Yep.
Sorry, buddy. Okay. Oh, actually, when I put my finger in to the port there, I can see that moving around. I can feel that piece moving around.
You can feel the tilt?
Yeah. Okay, so I'm going to put the antenna back there.
And then we're going to flip her upside
down. Turn her over.
Oh, it's a little purring sound. That's interesting.
Wake up!
Oh, okay. So this is an interesting thing with this product. They know kids are going to handle it without it being on the stand. So notice it's not doing any of the wing flapping or the telescoping.
So it somehow knows that you're holding it, and it's not going to try and move its motors against your hands, which could break.
Exactly, and that must be with the way this feet gets plugged in.
It's a great sound.
I turned off the sound.
All right.
So let's go unscrew the battery component in the back. I think it's just these 3 screws.
And this is where the batteries go in?
Yeah.
Oh, wow, the whole bottom plate comes off. All right.
Goes. And I will take those screws. Oh, those actually just sit nicely, just stay inside.
Here come the batteries. Oh, they're captured.
Yeah, that's nice.
Oh, good. Oh, that's really good. Okay.
This side.
All right. And then
it looks like, how many you got?
I'm going to guess I start with these 4.
They're the most
these may be
ones?
secondary.
Yeah.
Let's just find out that. You want to do the other 2 while I'm doing these? Oh, there's actually a spring on this one.
Okay.
That's closer to the center.
Ah, okay. We're inside.
We are inside, and it seems to be that all of the things we were just holding, all the screws we just undid, were screws are occasions in which the screw boss itself was the track that the telescoping happens on.
Mm-hmm. And those springs was that motion. So
The springs was accommodating for a little bit of resettling in that motion. Those springs went here on either side of here and here. Mm-hmm. So I guess this can move up and, oh, that's just providing a little bit of strain relief because this is where it comes up and down, right?
yeah.
It moves that and then it moves up and down on these screw boss shafts. So we have here, let's see, we've got a little speaker.
Speaker.
Comes up there.
Makes sense.
The batteries. What is this little doohickey here?
Is that on the bottom as well?
There is no interface, but it is a little battery regulator. Oh, right. Yes. This takes the battery lead and drops it down 3.31 volts. I'm not sure. It could be. And then just a little power regulator. Anyway, we also have, okay, that's...
So you have three lights.
Mm-hmm.
The two eye lights and a mouth light.
I kind of want to pull a little bit more.
Oh yeah, let's take more apart.
Okay. This is a speaker.
Mm-hmm.
The unit comes out, and then you can actually detach this grill top from it. And this sits on the outside, that little hook. Okay, so there's the speaker. I can't pull much more out of there. Oh, nice little feature here. They've included the ability to pull the wings totally open or close them without harming the mechanics. This is a little gear activated wing here, but they've also included a little torsion spring so that you can pull it up, but you're not harming it by like stripping the gears out. This is the center button. I like this, taking apart a brand new toy. This is kind of what I do anyway when I get one. All right, I'm feeling some, yeah, it's pushing up. Ooh, there we go. All right, if you let go.
Yep.
There we go. Okay, so now there's more springs. Okay, so, right, its orientation is clear because there's only one way that it can go on. But this is, oh, okay.
And this is that tilt. Will the tilt
This
happen?
is the tilt, but I'm trying to figure out what activates the tilt.
I see, yeah, this.
Because these four raise and lower it,
Yes.
right? And there it is.
Right there,
Right there. Yep. And it just tilts it back and forth. So it gives it the ability to tilt back and forth. But check out how much strain relief they've put on here. Again, with springs.
Huge springs, yeah.
Accommodating for the muscular little hands of children who can destroy toys very easily. This is the center button.
Okay.
And yes, there we go. Center button's out.
Wow.
And actually, I can put this back in there for safekeeping.
Yep.
And then that disconnects. Oh yeah, look at this. It has two different switches for two different positions.
Yeah, and that was right there.
Mm-hmm. Yep.
And
it's got a little step and a little second step.
And by pushing in, for example, by placing it in on the feet here, that pushes this up. Like if I place his feet in here, then this arm would have depressed those buttons.
And the different button is pressed by the hovering.
Yes, by the different stand.
Okay. I think, okay, so let's see. I feel like I want to pull off the outer, this shroud here, yeah?
Yep.
Okay.
Now diving into perhaps how the wings might work. Once we get that.
Yeah, the wing work is a really, so that is there's got to be 4 separate motors in here activating everything, right? Oh, right, that's where the microphone is. So this is holding not just the outer fascia on. Ah, oh, wow, okay. So this is going to be, this holds down the, so are these the same length?
They are.
Okay,
I have
great.
4 of them.
I believe it looks like almost all their screws are about the same length.
If they're the same threading. Yeah.
Yeah. Okay, so that's the light. That is simply the light. And this is the light shroud. Yeah.
So that's your diffuser slash eye.
Yep. And here comes the microphone. Come on. Oh, do you all just come off as one? Oh, so apparently you do.
Does the whole thing slide off?
It, not just yet.
I'm digging no
glue.
glue.
It looks like more wants to come out before I do that. And I'm just, let's see here. Okay, now this guy. Yep. Okay, right. So there's another place that it rides. It rides there on those two rails. That's the other part of the telescoping of this. So it's not just counting on these. These are secondary to that. That's neat.
And these are metal. These are solid.
Yeah, those are actual, probably steel even. It looks like. See, it looks like. Oh yeah, I can get the wing out this way. Okay, we're gonna pull the wing here. I kind of want to. Ooh! There
twisting?
we go.
Oh,
there we go.
Wow.
There is a wing, and here comes a wing torsion spring. And here comes another wing. So I can lift up the skirt here and get to the screw underneath. There we go. And it's another one of these long ones. Oh, it's not quite big enough. Oh, there we go. And there's definitely like a screw boss right in the way there. Oh, come on. There we go. Now you got it. Okay.
got it.
Okay. And another wing. Oh,
Interesting. Are they different? That pop off?
it does.
Oh.
Ha!
So
I
you
didn't have to
didn't
go
even-
through all that
no.
work. The wing just pops right off. I'm annoyed with myself, but that makes total sense. That allows them to be far more configurable.
Okay, that's actually interesting because then you can see on one side we've removed the spring and the actuating part. Other side it's there, so you can see how it actually moves those wings. And it's neat. Okay, so the wings do pop off. Makes sense. Kids are going to want to pop them off.
It does, and then they can just pop them back on. And,
There it goes.
right. So that is really nice bit of expandability. So that there's a fun rule in making props for theater is you cannot believe how damaging actors can be to physical props. And I'm sure in the toy industry, it holds true for children as well. Thanks again to iFixit for sponsoring this video. This week, iFixit tools are up to 25% off. And for years on this channel, I have used tools from their wide array in every stripe of project. And they sell tool bundles that can accommodate every kind of maker, tinkerer, and inventor. Recently, they sent me this magnetic fix mat, which holds the metal screws so that they don't go anywhere. They're releasing this in December, and it will totally help me keep my builds organized, which I can always use. iFixit also offers a lifetime guarantee on their tools, which is highly appreciated by people who are as tough on their tools as I am. You can go online and find the iFixit kit that is right for you. Plus, if right now you go to ifixit.com/tested and use the code CELEBRATE, all caps, you can get free shipping on orders over $65. That's the shroud.
Hey, there it goes.
There's your little microphone, and the microphone is actually ensconced here in a little rubber gasket to actually shield it from some of the direct touching of the unit. Okay. And now there's still no visible screw, so I got to go from underneath. Now I feel like we can start to pull the three. These are three main springs that hold this whole thing.
Oh, wow, that looks like it's a lot of force.
That goes with that. It is a lot of force. Yeah.
Like I was saying, it looks more mechanically complex on the inside than I imagined by those 4 movements we saw.
It's funny, yeah. You tend to open up electronics and expect to see something, right? And then it's I think you're right. It is actually, so what I'm looking at here is a single in-molded body that houses all 4 of these motors. Okay, there's the other wing arm. And there should be another little torsion spring here. Oh, there it is. Okay, great. Okay, so we are almost have this thing all the way apart. Ah, I see your galvanic reactance.
Yep, that's a capacitive sense, right? That's where we can detect the petting and the tapping on the top of its head.
All right. I'm going to give you another screw. This is a tiny screw for the front eye. Oh, I lost it. There it is.
Drop it right here. Thank you.
And then the second one. Oh, there we go. That's part of the eye.
On the outside, okay.
And here comes another part of the eye. Oh,
and that's the one right there. Yep.
Yep.
And that's the housing.
You can't.
Oh, interesting.
The galvan. There's a. Yeah, so it's got a little light pipe in there.
Yeah. This is the light pipe, and it's an angle, of course, because there's a
it
bevel at
faces
the top. Yeah.
And it feels very much camera eye-y like when it's on and it's functioning.
There it goes.
There you have the top. And now that is the entirety of the brain of Lola here.
Okay, let's take a look at what we got here. So this is our touch sensor on top. This is one of the eye lights.
Yep. That's the main eye light.
The blue.
That's the secondary eye light.
Right. So kind of a large PCB just for one diode.
Surface mounted.
Yep.
LED diode.
Oh look, the bottom here. So I guess that must be the purple light. So on the back of that board. Okay.
So what we've got here is it actually looks like a single motor. Which makes me wonder about what's going on inside here.
Is it some type of cam system where one motor, one rotation activates 4 things?
With some type of way to gear between them. I guess you're right. I see only one little DC motor here, which is right here. And that makes me want to crack this all the way open. Okay, so I'm going to pull this circuit board here. I really just want to, I love the idea that this is one motor doing all of this. So this is for the main circuit board. And so is that. And then we're going to, come on, there we go. Ah, that's it. Okay, so that is the 2-position switch.
Right, very cool.
And okay, so in here is a slip ring that's registered. And here this slip ring slides over this commutator, and different aspects of this get controlled.
So, whoa.
Mm-hmm.
These contacts, like 1, 2, 3, 4, are each on the different ring here.
Mm-hmm.
But depending on the orientation of this ring, only so many of these will be.
It's basically, yeah, it's
like a
basically
control
like a little analog relay system in which this can change its position and make different connections across this to activate different parts of this. But I'm still not positive I understand how this motor, how it activates the other parts of this. That's the thing I'm curious about, is if the motor turns. Oh, yeah, so that is a really fascinating little bit there, and it sits right here on there and spins around, creating different situations of connection. V motor, ground, pulse width modulated. Wow. Okay. I just wonder if there's not some extra servos inside here, but I guess the only way to find out is to start to take it
Yeah,
apart.
because I only see one connector for power.
I only see one connector for power. So how does that power distribute around to these other things? And
Because you got to have some way of turning this disc as well, right?
so that would be presumably what the motor is actually turning.
So it's geared from where we see the motor
Up there?
to.
That's a good question.
Right, we think that's the motor.
Oh, that's the motor.
That's
without a doubt, that's the motor. Yeah.
So yeah, power here. That's the motor. It's being geared in a way to turn this.
Yeah. Well, let's crack
right,
it open.
Yeah.
All right. There's the motor.
Yep,
It's a tiny little worm drive that drives. Yeah. Okay. So that tiny little worm drive drives this. And that in turn
these arms.
Right, but only those arms? Oh, wow. So
there's a lot of interesting gearing going on.
Yeah, I think that the way this works is that this is a little stepper motor, and it's pulse width modulated in terms of its power output. And it spins this gear.
Yep.
But when I spin this gear, notice I get movement on these guys.
Yeah,
See
that one right there. Yep.
So those are movement on wings.
Yep.
Okay. And then once I start to keep moving this, then I get movement on this guy.
On the body.
Uh-huh. So what that tells me is that there are different actuations depending on where in the rotation it's happening. So it can move to one section and move back and forth, and the wings go up and down. It moves to this other section and it moves back and forth, and that is the body going side to side. And then there's a third section it can move back and forth, and that's the telescoping. Okay, so let me see if I can explain this even more clearly. There's one motor with a reduced gearing that it outputs to, and that gearing turns this master large part. And as it spins, it can move to one section of that master disc that activates the wings, another section of that master disc activates the side to side, and the third section activates the telescoping. So it's probably delineated into 120-degree increments where those actions can happen. And the turning of the commutator ring here tells the electronics what's happening.
Where it is.
So they know, oh, you're in wing mode, so I'll make wing noises. You're in this mode, I'm going side to side noises. That's beautifully ingenious because it means they only need one little tiny pancake motor like this. It doesn't, it doesn't need a feedback loop to the motor because that's what the commutator ring is telling it. You're just moving over here and doing your business. Okay, now you're moving over here and doing your business.
So it can never do both at the same time. It can't do wings and telescoping.
Well, maybe there are transitions between them when it can do a
Oh,
little bit
okay.
of both.
And that's all in how it's translating this into your big gear.
So I'm holding back this one really cool thing because, and I'm about to drop it. We think that we're in this golden age of toys because we can fit so much into so little. And even with the advancements that we currently have and motors that are this tiny, we still have to make this bigger than the filming prop in order to get the amount of strength and functionality and robustness into the toy. But this solution, which is a beautiful, beautiful solution, is actually incredibly old as a solution for electronic toys.
It's kind of like an old automata.
It really is. They're getting a lot out of very little, and mechanically, from a design perspective, that is a magnificent little bit of design, of physical engineering, because they need very little travel on these to raise it up and down. And I'm sure same thing here, very little travel on this arm to get it to move back and forth. There it goes.
Yeah.
That's its main interface with the bot, is turning that little wing. It's turning that little gear. And then that large gear turns to this, which then connects up to this main. You can see that main gear turning here. Yeah. And so as I turn it, at times in its journey, I activate up and down, and then I keep moving it. Now I get wing movement. Now I get body movement again. Get a little wing movement. I mean, it's totally fascinating. And then I'm sure that within this, I'll feel at some point in its journey, this little thing will move.
And those permutations, that's all mapped out in their software. The control board knows its position.
Right. It understands precisely where the position is and takes and uses this bit of electronics to let it know what's actually happening and where it is. I love how old school this solution is. And that is deeply thrilling. Oh, we can put that microphone there. That is a really, really nifty solution for getting a lot out of a little. We can keep on taking this apart. Okay.
Ooh. That looks complex.
It does. Okay, so let me. Oh, that's not the one I want.
And this is everything's, that's the gear. That's the primary gear. Oh, wow. Okay. Look at that. Look at that. It's like a cam.
Yep. So it's a set of different cams. And depending on where it is in its travel, right, this top cam is moving back and forth.
And it's stacked. So that they're on different layers for the four different movements.
So this cam moves back and forth and activates up and down what is happening.
Mm-hmm.
There it is.
And you have your gearing here for controlling that movement. And then the second cam, this arm, so it's 1, 2, 3, 4.
Yep.
There you go.
Those are the wings. These are wings moving back and forth. Wow. All right, so let's see if I can. Okay. Yeah. So one cam moving. Oh, wow. It is so much more than just a cam moving back and forth. It's where this is underneath here activates the up and down. So this sits inside here, and this one, as it moves this paddle back and forth, and that adjusts that and creates the up and down.
So it's not just pushing the left and right for here, it's also taking into account.
Yeah. Well, so that one is the side to side, I believe. And this is this business here of back and forth here, that's the up and down. But notice that there's like, oh my God, this is, I'm not going to fully solve this in my head right now, but that is a beautiful. Oh, hey, stop it. That is just really thrilling how. Yeah. And it's just these two racks moving back and forth. Yeah. And then these guys sit there. So that's the transmission of this unit that allows 3 completely separate axes of motion to be controlled by a single motor. That is just really, really neat. Just to be clear, I haven't wrapped my whole head around exactly. I'm getting close, I'm sure. My mechanical brain does not extend to being able to visualize the. Oh, wow.
Yeah, I'm
You
looking
see
at
this? Do you see
they're-
that? That is all about the animation of movement of the wings, all that business. And then this is the same, probably in reverse, which allows the same movement on the other side, but also perhaps slightly out of phase. Remember how I said they didn't open and close directly? That wasn't a programming thing. That was a mechanical thing. They can only open and close in a couple of different orientations for animation. Wow.
and it's manifest in a very physical way.
Mm-hmm. Oh, man. I'm sure the original engineers are watching this laughing at me being both close and also far from the actual solution. But this right here shows you that is the sum total of the movement for raising and lowering. And on this gear, it is literally, it's 90 degrees of turning on this. So with a very small amount of motion on these two, we get the full telescoping movement. And then by the same token, a very small amount of motion on these two, on these guys, we get the same thing. Ingenious.
There you have it.
I really appreciate this kind of dive. I love it because if you think about designing a toy for kids, your first thought is they're just going to try and destroy it all the time. They're going to throw it. How do I make this thing able to handle being thrown and abused and beaten and chewed on, and the dog will run with it and all of that? And we've seen like 6 different mitigations for abuse in here. That's really cool.
And with just 4 fundamental basic movements to still have a character and a personality, obviously combined with sound effects and lights.
Yeah.
Like that's the power of like puppetry and animation.
Yeah, and that's a tricky one, right? Like they've got to, once you're designing this, you've got to figure out how much is possible with the limited motion that you've got. If I only want to do this part, that motor can move over to this section and just do this and open it up, and then it moves on to that is just really, I'm super impressed. I did not expect to, I thought I'd encounter 3 or 4 separate unique systems in here, each which were programmed. And the genius is much of the programming is in the mechanical operation, not on the IC board, not on the integrated circuit.
Well, I'm sure it's more cost effective just to have one motor as well and solve that problem mechanically.
Yeah. I could keep on talking about this for hours. This is our friends at Hasbro. Is that correct?
Yeah, Hasbro sent this over. Let us take it apart, and it's just a fun way to look at the design of modern electronics, modern toys.
Is that a reasonable place
I
to
think
wrap
that's a
up?
great place to wrap up.
Dudes, thanks for joining us on this deep dive. I am not going to reassemble this toy.
At least not on camera.
No. If it is reassembled, yeah, we're just gonna have to rewind this video to do it. But thank you for joining us for this. And this is a lovely, lovely toy. I'm really impressed with it. I want one for my house.
Lola animatronic from Obi-Wan Kenobi. All right, thanks everyone. We'll see you next time.
See you next time.